Welcome to the AStarStartup Daily Stand-Up. My name is Cale, founder of the AStartup, and this is the first time I've ever done a daily stand-up. I run a lot of GitHub organizations. I manage hundreds of repositories, so it's kind of a little bit of a struggle to make progress because it really does take a lot of focus on all of these different startups to actually make any progress. Like you can't just like learn through osmosis and meditate on it, then like do some like hand wavy shit and then all of a sudden now you got paying customers, right? It's not the way it works. So I think recently I've been a little bit better about staying diligent. I have been dealing with a lawsuit. It might be very interesting. I'm about to get the Ninth Circuit Court of Appeals to ban state use of preponderance to take our evidence. You got to check this out. All right. So this is infuriating. Okay. It started out that the court would instruct the jury to say, you got to balance the rights and the probabilities. But then a court ruled that that was unconstitutionally vague. You know, you've seen the picture of Lady Justice, right? It's got the scale. Like that's what the whole thing is you've got the probabilities and then you've got rights, which, you know, just because the probabilities are equal doesn't mean that you're overcoming this person's rights on the scale. That was like the core of our legal system at the beginning. And then they replaced it with preponderance of evidence, which means that it's like 50.1% likely, which, if you ask me, is way more unconstitutionally vague. Because, one, what the hell does that even mean? What does 50.1 mean? More likely than not, translate that into English. It means it's dependent on whoever your jury and the judge is and whether or not the judge's favorite sports team won the night before or lost the night before. And so that is capricious because it's all dependent on random happenstance. There's no logical hysteresis mechanism. So in a thermostat, in order to get the thermostat to turn on, the temperature has to go up a little bit over the set point to turn on. And then to turn off, it's got to go a little bit below the set point. And the reason for that is that without that, the machine would turn on and off rapidly and it would destroy itself. So I argued to the court that the lack of the hysteresis mechanism is also having that dangerous property of it. But what they did was they basically took our rights off the scale. So it used to be that, you know, they would just because the facts were, you know, in both parties' favor doesn't really tell you whether or not one person is supposed to win because, you know, I have rights and you have to overcome those rights. So how'd this happen? My engineering school expelled me because I wrote some insults to Democrats on my vaccine mandate waiver email for a religious exemption. They don't really allow you to classify whether or not you have a religious exemption, but they said that I disrupted the administration of the school. They expelled me using no evidence because I she told me this chick, this short-haired butch. This is how it's described in the court papers. It says a short-haired, butch-looking woman with she/her in her title, or no, she/they. So, I mean, it was pretty clear from the get-go. You know, this chick's got colored hair. You know, she's a radical feminist. You know the way it's gonna go. So I put in a written statement, putting in my sincerely held moral and religious exemption or objections, and then they just disregarded those. And They kicked me out. Well, I was supposed to write some sort of like paper about how I'm a bad person and what I did was wrong, but I just sued him for $2.35 million, and then like the trial judge, his wife turns out to be a U.S. Congresswoman, Susan Bonamici, U.S. House Rep for Oregon. So I told him, I'm like, yo, all these comments are directed directly at your wife. Like, you can't be sitting on the bench for this trial. And like, dude didn't care. It's like, hello, you cannot be sitting on a trial that where somebody's insulting Democrats and your wife is a congressman. Like, hello, do you understand how other people are going to be looking at this? They're going to be looking at it like, yeah, this dude is a corrupt clown. He put a temporary restraining order on President Trump. So he's one of those activist judges. The magistrate judge, he had gender pronoun rules. He was one of those freaks from University of Oregon. The woke ducks. Unfortunately, yeah. I'm sorry if that was your favorite sports team and I just ruined it for you. Yeah, people are insane woke here in Eugene. The crazy white liberal feminists are like, they're on one, bro. Like, they apologize for being on stolen land at every meeting for like the 4J school board, University of Oregon. It's always the same cringe thing. They're like, say what the name of the tribe was and like about how bad we are for stealing their land, and it's like then they plug BLM. It's like, oh my god, what happened dude? The DEI freaks just went crazy, bro. So what was I saying? So I just got sidetracked on that. Was there anything else interesting about that? Oh yeah, I'm reforming qualified immunity if I win, because I filed a Section 1984 action at law and not a suit in equity, because my suit in equity was under the Oregon Tort Claims Act for a personal injury lawsuit because I did not suffer property damages. I suffered personal injury damages, even though some of it was reputational. There's also this long story, I don't really want to get into it, about my son getting kidnapped. That when the state used preponderance to give his maternal grandmother custody because I used a baby monitor, and I had friends over and I yelled at her and said I'd stop talking to her if she wouldn't stop alienating me from my child. I know it sounds so freaking crazy. Like, what you're like, what are you talking about? That everything that you just said was just absolutely like batshit crazy. Like, take somebody's kid away because they use a baby monitor. That's what they sell them for, right? But that with the preponderance of evidence, that's all they need. That's literally all they need. It's infuriating. It ruined my reputation. Ruined school for me because I had to like take the Amtrak back and forth to Eugene. I wasn't able to get into the labs. I suffered from complex PTSD from being dragged through the court system, being in engineering school, and then everything's just like, they were like charging me full price to retake classes, and I couldn't graduate, and then I couldn't get money for an attorney, and so then my kid was getting neglected by the grandmother because she was just as crazy as her daughter was. Yeah, that's why her daughter was crazy. Why am I talking about this? Anyways, they used a preponderance of evidence against me. And so I am demanding to get my tuition money back, saying that my mom didn't agree to any of this. So I'm like asking for the money that my mother gave to the school because she got suckered into it through a predatory loan. And then PSU made it so I wasn't able to graduate by expelling me. So now they have to deal with the tuition overcharges under the American Disabilities Act because I'm entitled to full access to the program, which includes graduating from the program and not just paying tuition and doing work for free, which that would be cool because it's all about the 14th Amendment in this case. And it is actually a case of slavery, uh, confinement against my will, kidnapping, causing total disability. It was, I'm pretty sure I'm going to win because they used arbitrary state power. All right. It's just wild. What the hell is going on? So the school, all of their power comes from this one law, ORS 352.087. It says that the school is, that all the school's policies have force of law. And so they fined me $20 for my speech when they expelled me. So I think they're screwed because there's no way that they're going to be able to claim qualified immunity in the appeals court because first off, I didn't ask for money under Section 1984. That's the federal law. I asked for it under state law. So we don't have this. They're saying they got 11th Amendment immunity, which says that you can't sue a state that you're not a resident of, but I'm a resident of this state. The courts have then said, well, we have to treat everybody equally. And so that means that nobody can sue the state that they're resident of in federal court. But it obviously doesn't say that. You can look up the 11th Amendment. There's nothing in there that says that. It wasn't intended to that. It was intended to prevent people from out of state from suing in federal court. If you want to sue a state you don't live in, you got to go to their courts. Okay. But they need to operate off of explicit powers. They can't just like make up some court precedent, because a lot of times with this court precedent, like the cases that they cite don't actually say what they're saying they say. They just cite them because it's so many different things. You'd have to like go through and like cite all the specific things, and this takes like an expert, and a lawyer might it costs you a lot of money, and then you're not guaranteed to win because of some other weird peculiarity thing. So people just don't even fight it. But I'm arguing to the court that the state officials cannot deny the charges because I'm entitled to the money under state law, and the state officials cannot abrogate the power of the laws that the people voted in just because they don't want to come into court. So this people in the state said, yeah, we're not going to take this lawsuit. We're objecting. But the thing is those people aren't the state. Those people just represent the state. The people, they passed the Oregon Tort Claims Act. And I am pretty sure that it's definitely not a property damage. I mean, it's definitely a personal injury. I did have complex PTSD from being dragged through the court system, and I have records. So, I mean, I might not have been hit by a car and been like disabled, but maybe I might have rather have that happened to me because it was so traumatic. Why am I even going over this? Well, this has been completely derailing my whole startup because I had to do an appeal, which took like a month nonstop, and I got it in within a few days of the deadline. And it was like, originally I had 100 pages, and then I had to prune that down to like 18, which was quite a bit. But I have a good template, and I don't think that you would be able to know that it wasn't an attorney that wrote it, because my template was so good and my case and the facts were so good that it lined up. Stars lined up perfectly, and we're almost certainly going to be getting a ban on state use of preponderance of the evidence, because you cannot deny they took our rights off the scale. When you look at the history of it, you're like, oh, so it used to say balance the rights and the probabilities, and then you took the rights off the scale. Oh, great. Right. Nobody with half a brain would like let that one get by them. That anybody is going to be like, wow, you took the rights off the scale, and then you're kidnapping people's children. Yep, they're Democrats, of course. Of course. Nanny state, thinking the state's got to do all this stuff for you and protect you. It's usually their MO. This isn't a politics channel, though. Sorry. hard not to talk about politics when it's like, well, it's definitely one party that's doing it. It's not like they're flip flopping back and forth, red and blue. So, what project did I do? This is the Script2 hybrid C++ API. And what is going on with it? I did some change this from a switch statement to a little bit more of a packed up table. This isn't a programming live stream though. This is a data specification that I wrote called the ASCII data specification. It's not the American standard. It is the automaton standard because, or sorry, an automaton. I say automaton. I don't know because it does say auto. But I'm all stalled up on it because it's very complicated and I'm doing remote procedure calls, and now we have like a complete radical change in the data specification utilizing this new extended type system, which uses where's that bit pattern? I got this bit pattern of like where we have illegal types. And then we also have these context specific types. And so these things, all these zeros are like, could never work on any system. So then I remapped them over to these things. And then in order to like quickly determine what table where I'm at, I like figured out this like thing where I could slide these tiles around in 2D, and it works really good. But then, it took so long to do this that, it's been like really, really difficult to try to get back into it after that month break. And it's like, it's been 11 months. And I'm a little bit worried that, this is like, the writing on the wall. It says the project is doomed. So I'm going to try to be like a little bit smarter about what I'm doing. That's kind of the purpose of what I'm trying to do this daily stand up for. But this isn't a programming channel. So I'm going to get back to here. So why am I doing this API? The problem with this API is that these APIs are extremely tedious. If the operating system changes anything, you're done. It's pretty stable with like the Win32 and the Linux. But what can I do with it? I have a MIDI controller API. I could make some MIDI controllers. That's about it. At one point in time, I had like a GUI library, but then got fried because the hard drive caught on fire and ruined everything. And that kind of sucked. So will it do anything? At this point in time, I'm banking on just making an AI-friendly C++ API. It's got the Script2 backend, which has an AI-friendly Crabs machine or a Chinese room abstract stack machine. And this thing can work asynchronously with these sockets. And it's kind of like JavaScript, the virtual machine, how it's like a round robin. I go through all these slots in a door. And I don't really have any like asynchronous stuff going on at this point in time, other than the like sockets API. That stuff's asynchronous, but I don't have like asynchronous variables right now in my script. That is like another level thing. So business wise, what's up with this? So why am I putting more time into it? I'm building what is called sub-second database. It's a Postgres extension. So we've got a in-memory database. It's like Redis, only it's all based off of this ASCII data spec, contiguous data types. And what is it? It's entirely experimental. It's extremely high risk. It's been devastating for my startup. It consumes a lot of bandwidth. It makes me depressed that it's not working. That slows me down. Makes me feel like everything's going to come to an end because I'm at the end of my rope and I have to come up with some stuff. So what am I doing? I'm trying to do 3D printing right now. I got like 10 3D printers in my house, and I'm making 3D printed rabbit houses. This project's called Hopping House. I'm pretty happy with the name. We're hoppinghouse.org. Website's not up yet, but we have basically source available 3D printable rabbit enclosures that use cheap playpen panels that you can buy off of Amazon. They're like 24 or 30 inches tall, 2 feet wide. And so we're just like 3D print up corners and make it so it's bunny proof and they can't like chew on the plastic. And you just get some thick hardware cloth. Forget what gauge, like a 14 gauge, I think. Maybe, yeah, that sounds about right. And then I'm building some sort of like system to latch the hardware cloth on for the floors. You know, you 3D print in some things on the floor, put the hardware cloth on, and then you make it so the bunnies can't chew on it. And that's difficult. You know, I don't really want people to have to like continually have to 3D print parts. But with the wood, there's all kinds of problems with the wood. It's a bacteria sponge for the bunnies. It's not that good. You got to paint it. The paint is toxic. The paint is extremely expensive. It's extremely laborious. Like we have a deluxe rabbit colony with I made an A-frame and like this like walk-in wood thing with like, you know, bunnies can run all around, and it took so much time, and it was like days and days nonstop of like woodwork. It was really stressful. My son was like completely useless at the beginning. He did get his stuff together, but like I had to yell at him a lot, and then the neighbor got all pissed off at me. And then, you know, now he's a lot better. It helped him out. Neighbor should have minded his own business. But I don't think that other people would want to go through that. It was extremely expensive. So I think personally that 3D printed rabbit stuff is going to be a big deal. So I'm hoping that this can bootstrap the startup. I think that it would be a lovely thing to be able to help out some bunnies and to be able to get enough money doing 3D print work to where I could hack on code, you know, keep an eye on the prints, you know, you'll have to go run and fix a print every once in a while, put another thing on the print. You know, I'm not trying to be like, you know, making a whole lot of money off it, but I do have a lot of other things. I can't really get too much into what the aerospace business is doing. I do have a stealth technology and a new propeller design, and I can't really discuss too much. But AStarStarship is a kind of like a big sprawling monster at this point in time. And then I got another business that the Exposio, and that's my live streaming app and my 3D printed camera accessories. And that one, it's like, oh man, I could work full time at that startup. And then what else do we got? I just keep coming up with these cool things. And, we got like the A Startup, and then we got the A Startup cookbook. There's the A Startup toolkit, which is going to interface with the live streaming app to add mission driven development. But I'm kind of a little bit losing, I'm a little bit losing faith in the system, which is pretty just nuts and bolts, basic operating system on GitHub. Like you make an issue ticket. I make a mission ticket. So everything's got a problem solution statement listing the files that are affected. I believe in the problem solution statement, but there's it's like, I don't really know if there's any better way of doing it than an issue tracking system. It's not perfect because it's like, you get this problem where it's like, in order to get work done, it's like you have to like complete a task. You take a task out of the mission queue and then you have to like go on the mission and then complete it. And like, that works great if it's a short mission. But if it's like complicated, it's like, dude, this mission could be going down for a long time. And then you want to like do something else. Right. And so then you get this problem where if there's anybody else working on anything, then, files get out of sync. It's like the GitHub does not allow you to like own files, individual files. I think that owning files I think that would work, because when you try to merge, I mean, it's like you got like two medieval armies that are like death and destruction, like fireballs, people are like screaming, dying all over the place. This is like pretty standard for most corporations. It's like the Hunger Games. Excuse me. But I don't know if there's a solution. I know that Prime Agents had this be one of the topics that they've talked about. Sorry, I got a frog in my throat. I don't have any water right now. So all the corporations are dealing with the same problem. When the shit hits the fan, it's like the only thing that can stop it from being a complete catastrophe is like having like a flight controller that is guiding the different people in when they're coming in for the landing with their code, and then you got to like redistribute it. And then people do this continuous integration, continuous deployment, and then you get this situation where the continuous deployment, something bad happens. Maybe they got hacked with the 0 day. Maybe it was a malicious actor or employee, I mean. Or maybe they just had a bug that took down the whole system. And it's like, okay, maybe you shouldn't be continuously deploying out to everybody's computers. I mean, I know that sounds great. And boy, they certainly do have a whole industry based around continuous deployment. It does seem to be recklessly irresponsible, and it is extremely annoying that they want to update the app every single time you open it. It's like in the mobile app community world, they get the data. The data is set up such that you are expecting people to not update the app very frequently. So this is where like React Native is going to come in quite handy, because you can change out the content dynamically. And this allows you to have really old version of the app function as if you're on the latest code. That does require a technological stack that I wish I could do with Script2. My ambition with Script2 the original intention was that I wanted to make it so that multiple people could debug the same robot asynchronously and get the data that they wanted. So that's how I got the Chinese room abstract stack machine and the addressing system using the sockets, the slots in the doors that you send messages to other rooms. And this was all like when before Transformers came out. So right when the Transformer was coming around, that was when Script2 came about. And it was basically a Transformer. It would have turned into a Transformer architecture. That's what I was trying to do with it, but I didn't know how to do it with self-attention. And I was trying to do symbolic tokenization, which, I probably would have given that up on that one pretty quick. But I strongly regret giving up on that project, because the way I was looking at it is from the perspective of what I was seeing when I was trying to create my own operating system. And I first tried to create my own operating system in like 2005 for Linux. And I tried to put together a repository. I had a package manager before they had package managers. And then my hard drive caught on fire. Lost the API, which was sad because, I could have been big in Java back then. But it was like a Java-based Linux distribution. So it would have been kind of like Android back in the day, but for like making music with. And then that project died, and then all the raves started happening, and then all this crazy stuff happened. I think I went into the court thing, and then I'm like an old man now. It's just kind of crazy. I still ain't even getting any money from this shit. So I'm gonna have to be smart. I can't like invest time into things that are bullshit. And so what else am I working on? I'm working on this like neural network random number generator. It's called the low rank recurrent convolutional random number generator, or LORC. And then I'm working on the S-Great pre-transformer, which is spectral graph token pre-transformer, utilizing a Laplace matrix in order to create nodes in a graph, to create like a subgraph and a row of a matrix using a Laplace matrix, where you just put a 1 if there's a graph node. Like if the token exists in a paragraph, I'm going to stick 1. So I got all the tokens. All right. And then I got what I do is I parse Wikipedia, and then I generate these graph nodes. And then what I do is I shift the tokens around, whatever token appeared. So I shift the index of the token. And what I'm trying to do is I'm trying to put the ones in the diagonal, and then in the opposite corners, I'm trying to get the zeros to clump up. Okay. And so my theory, and then what do? We take the largest eigenvalue of this matrix, which is very large. And what we can do is we could use this in order with spectral graph theory to sort the nodes, utilizing, AX equals lambda Y from linear algebra. I don't know if you remember this. So we could, utilizing this with the largest eigenvalue, we can sort the nodes by energy transfer through the nodes. So what the spectral graph theory is used for is to calculate the energy transform in a quantum system. So in a quantum system, we have a lot of different parts. When I say a quantum system, I mean things that are on the atom level that consist of the system that's on the atomic level. So a quantum system it's not just like the quantum mechanics. I'm talking about the atoms and the system so you got these networks of atoms, and they are connected through bonds, various different various different things. Okay, I can't be having this lame of an explanation. I know more about quantum physics than that. So there's when if you look at a system that has energy flowing through it, you're going to see with the nodes that there's these choke points where the energy is at. So with the spectral graph theory, we can see where the energy is coming through the largest amounts in the network. I'm sorry, I don't have a more detailed analysis than that. I am not a quantum physicist. I am an amateur who knows quite a bit about quantum physics. But I'm trying to utilize this because what we want to do is because the eigenvalues are going to start to get gigantic whenever we compute them, and then it's going to be computationally too expensive to calculate up these eigenvalues. So we only want to look at the maximum eigenvalue, and then we utilize that maximum eigenvalue in order to sort the rest of the tokens, because we take knowledge domains. So we'll parse like categories of Wikipedia. We will make one row in our Laplace matrix for each paragraph, with one in the column where each of the tokens exist in the paragraph. This is going to give us a subgraph for an idea. Okay. And then we're going to examine the energy flow between different knowledge domains. And what we're going to do with this is we're going to make it so that we can utilize this information to sort information in an LLM, in a standard transformer model, such that concepts are, for lack of a better word, at the same elevation. So imagine that we have that your LLM, all the neural networks, the values for your transformer architecture, all your dot products, that this is like a mountain, right? Just imagine it's like just 2D. Don't think of it as like a bazillion dimensions. It's just a 2D or a 3D mountain. It's like, it's just got a 2D plane that's got like a topography thing, and then it builds up and it's like a mountain, and there's like peaks and troughs, valleys. So what happens when we order the tokens utilizing this Laplace matrix diagonalization, or it's not diagonalization, that's probably not the right word, grouping the ones in the diagonal and the zeros in the opposite corners, what you're going to find is that the dot products then start to cluster around in the middle, because it's a range thing. It's like we got them all in the diagonal, right? When we did our Laplace matrix and we sorted them. So now most of the nodes, when you multiply them together, it's like kind of like akin to squaring the number. Okay. You see where I'm going with this? See where I'm going with this? It's pretty clever. I'm going to have to pat myself on the back. That is extremely bright. If that works, I have definitely cemented my name in AI history. I'm pretty sure that that's going to work, because well, let's say that the tokens are distributed such that we don't have the clumpings of the zeros in the opposite corners and the ones in the diagonal. Okay. So what is that going to mean? That means that when I do a dot product, that that dot product is going to be all over the place, right? So the question is, do we want it to be all over the place? Because we might not want it to be in a diagonal. I'm just assuming that we're going to want it to be in a diagonal. And if that is true, I think that we're going to be able to chop off half of the memory space because we chop off a half of the dot product space. And when we do that, it's like we're going from 1 terabyte of RAM down, or 2 terabytes of RAM down to 1 terabyte. Or if you were at 1 terabyte, now you can fit everything in your 512 gig Mac for what is it? A5? What's that chip? Oh shit. I don't know. Apple's. I definitely. I mean, I'm not dogging on them, but I mean, people. This whole idea that I should like leave Windows because they're forcing me to sign in and then go get a Mac is complete retarded nonsense. It's ridiculous. Everything about it is dumb. Because if I get an Apple, I'm going to have to sign in with my Apple ID. It's like, okay, all right. So I know you guys are upset that you had to sign in with your Microsoft ID, and I too also am upset with the ads. I got one maybe today or maybe yesterday. When I logged in, they're like, hey, configure all your smartphone stuff. It's like, I already pay you for OneDrive. I pay you for Office 365 and for GitHub. Okay, you're getting $18 a month from me. Why the hell are you continuing to bombard me with ads? I'm already paying for Copilot. Okay. It's, stuff like that is frustrating, but I definitely would not be going to Apple because of that. I definitely would be going to Linux. There's no way in hell I would be going over to Apple because of Microsoft becoming a big tech giant. It's like everything about that is dumb. All right. Do I have anything else good to say? I want to go do some other stuff. Wait, business wise, this is supposed to be a startup live stream. This ain't no like live coding live stream, right? So what's the business takeaway? So like business takeaway of this, if I were you, is I would not start anywhere near as many businesses as me. I can't get as much work done as I would like. Like you could see everything is extremely complicated. It's like I had to put every bit in exact places. And like that amount of time was like years. And I mean, I'm not going to be on the streets, anytime soon, but I might not be able to retire if this project like goes bankrupt. So I'm going to have to do something. I don't know if I'm gonna have to like cancel some businesses because I like a lot of these businesses. I got like the what do I got? I get the organ cooler, CO2 sequestration. Well, it's more like CO2 concentration machine. I'm using plants to get the CO2 out. I'm just concentrating it with water vapor. And I have a bunch of other tricks too. I've actually got some stuff I need to get a patent on for my thing. So what do we got? There's the AStartup, and then that's got the Mission Control Center, which is the Chrome extension. And then I haven't even touched that in months. I started doing sub-second ID because like, what was I doing? I was doing AppWrite database, which is cool. If it works for you, it's going to work. They didn't have a C++ API. And so I jumped ship over to Postgres, which I'm glad because I was giving up on Script2 because I'm like, AppWrite has redis. I mean, how much money is it in this market? You know, you're competing with the biggest guys out there, uh, competing with GNU. You know, how am I going to make money with this? So sub-second database, you know, I can make some money because we got this 64-bit UUID library. Don't have that posted up. I've almost got it working in TypeScript. And then I started doing the LLM, or sorry, the neural network based random number generator, which I think is going to work. I'm using a method of multiplying. So I'm not out. I mean, programming the thing by hand made me realize a little bit more about neural networks that, you know, the TensorFlow was doing for me. You know, it's like you got to think of the deep layers in the neural network as if they're like binary. They're like on or off. And so like they have a number on it, but it's like a threshold. Once you get up over threshold, then the neuron's activated. And so, you know, I would recommend that you build a neural network random number generator, because I thought that it was for like learning mathematics and science. I thought it was, or computer science, I mean, I thought it was extremely useful because you have to deal with exponents. And even though I authored the world's fastest integer to string algorithm, which you can read in the Script2 wiki on GitHub, it's Puff, as in Puff the Magic Dragon, and uses discrete mathematics to eliminate over half the division instructions from the mod 100 div 100 loop. And I thought I knew floating point really good, but apparently I didn't. So making the random number generator was that was helpful, because, you know, you got to understand where the hidden bit is. Like I didn't understand enough about the hidden bit. You know, what you have to understand is if the exponent is between 0 and the number of bits in the mantissa, there's a hidden bit. Okay. If it's less than, if it's less than the number of bits in the mantissa, then, and 64-bit floating point number, that's going to be a 64-bit. I'm sorry, that's going to be 52 bits in the mantissa. And so if the exponent is 52, then it's going to be 1 point whatever. All right. So if it's like 51, if the exponent is 51, it's going to be 0.1 something or other, because it shifted over 1. It's not like if the exponent is 0. For some reason, I thought that if the exponent was 0, then it was like 1 times something or other times, you know, I'm base 2 times, let's say e to the 2. No, that's not capital e to the 2. I don't know how you say that. The exponent, exponent 2. So if you're going to do a neural network based random number generator, it's interesting because you can't have too many neurons going. So you have to configure your neurons in an optimal setup so that you have the most layers as possible, and so that you can detect the data, because you need a certain number of perceptrons to actually even identify the pattern in the first place. So the interesting thing about this is it's a LoRa. It's a low rank adaptation. So I'm talking about LORC, LORRC, random number generator. And so the technique that I am using is it outputs a multiple. So you input in a number from -1 to 1. I'm going to use this, shoot, I can never pronounce it. What is it called? Polar method. It's a town in Italy. Marsaglia? No, Marsaglia? Marsaglia. That is just so hard to pronounce. Polar method. It is it's very interesting math behind it. If you like mathematics, I would highly recommend looking that one up because it is all about the probability distribution. Sorry, the cumulative distribution function, the CDF, or sorry, the probability. No. Yeah, so there's a probability distribution function, and this tells you within a range what the probability is given by the area underneath the curve. Then you've got your cumulative distribution function, which says that the percent chance of any number over a certain number. And so the Marsaglia polar method is interesting because it utilizes some calculus on the probability density function in order to minimize the number of e to x calculations that you have to do down to one, only one e to the x calculation. And it's still a pseudo-random number generator. It is not a quasi-random number generator. What it happens, so it has some issues with the output distribution is kind of like jerky. Like it has like it doesn't like it doesn't add up to a perfectly normal distribution. But what I'm doing is utilizing the neural network in order to correct it. So the Marsaglia polar method is a good quick check to see whether or not it could not possibly be a uniform random number. Uniform means that it is like any number from 0 to 1. It's not like it's like perfectly uniform. And then when you add up 12 of them, then you get a normal distribution, aka a bell curve. And so what I'm doing is detecting that a value was not in a normal distribution. If it was not, then I output a multiple that I multiply that number by. And the reason for this is the interesting thing that I learned from this is that I don't have enough resolution from my neural network in order to actually have a random number output. I would like to be able to just like have the neural network output a random number. But the thing is that it's not going to happen because you have to understand how it forms a normal distribution in the first place. Right? This is the core of the central limit theorem of statistics, is that when you add up a bunch of uniform random numbers, they start to form a normal distribution once you add up 12 of them. And so the thing is like the most of the bits for the randomness don't really actually matter for like the randomness of it, whether or not it's actually a normal distribution. Because you got to think, I got a mantissa, I got a hidden bit, right? And then most of that mathematically doesn't really do much. It's like, I've got like 1.011101 whatever, but like there's only a certain number of these digits that actually are going to matter for the randomness of my algorithm. So I leveraged this actually in order to generate pseudo-random numbers by using a CPU-based neural network where anytime I do a floating point division instruction, I keep a running XOR. And then this has pretty random bits. It's actually pretty good for randomness. And then I just basically just rebound it. So I take the input number. So you give me a number between -1 and 1. And then I'm going to generate a pseudo-random number between -1 and 1. I'm going to XOR them together. And then I'm going to rebound that between -1 and 1. So this makes it so that on my web server, I don't have to do as much processing power because I'm getting a pseudo random number from the client. It might be a poison number. They might be trying to hack my thing, but they can't hack my thing. It's not really possible for them to hack my thing. It wouldn't do anything. I would just multiply it by a number. It would just whack. It would go, whatever it was. It's like you're just affecting some of the least significant bits. But that doesn't matter for the randomness of it. The randomness of it is actually more based upon the exponent than the manticipants, right? So, yeah, I feel like less of an idiot after doing that because, like, statistics definitely made me feel like an idiot. Like, when I did statistics, I think it was kind of like a blur at that point in time. And I got a C. And I think the teacher might have felt bad for me. But what was it? What did I fail? I think I just missed some assignment or whatever. I probably could have done better, but then this other teacher was slamming me, and then my teammates bailed on me. I had to do the whole project by myself. And they were like, oh, let's just do it at the very end. I'm like, yo, you guys, you can't do this. And they just like failed, and I got a bad grade in both classes. They got a good grade. That really pissed me off. Made me understand exactly how retarded people act. Especially like the teacher was like, he was like an alcoholic PhD guy who was like a good looking dude with a beard. And he was always late, and he was always kind of sloppy. And he went to school in Germany, and I think he went hard, but like you could tell the dude like drinks, and he just wasn't on top of his game. And then he was like trying to hit me really hard because those other guys, I was trying to do it in Xamarin, C#, and then the other guys weren't having it. And so I did everything because I'm like, whatever, it's just C#, not that big of a deal. But then Visual Studio made some big update, and they broke everybody's computer right in finals, like right before we went to go do the demo. And I couldn't even load the thing. I had the thing, it was working, and then we had to use like a mock-up in the presentation, and then I did everything, and I thought it was okay personally. But then the teacher thought he hit me hard for like, I don't know, because I wanted to use Xamarin or something. It's like, whatever, dude. You really wanted me to use Java? Make us use Java. He was like, "Oh, use whatever you want." And then, oh, why am I even talking about this? Statistics. Oh yeah, I feel a lot like better with statistics after doing the random number generator, because you really do have to look at all those things from that intro statistics class in order to make a random number generator, right? Because, you know, you got your probability density function, and then you can go look up those 3 blue, 1 brown videos about how the probability distribution function works mathematically and how you can make it like 2D or a 3D probability density function. So that's the next step with the random number generator, is the 3-dimensional probability distribution function using the Marsaglia polar method uses 2 values, x squared plus y squared equals 1 deal with a unit circle. But I'm going to try to attempt to expand this to 3 dimensions, because I want to utilize, I'm taking, what I did was I have a LoRa low rank adaptation neural network. I split this thing in half diagonally. Okay. And then instead of having like the neural network be like a bunch of layers in a square, which would make sense, right? Instead, I'm doing split it in half, and then I split both halves up into 5 layers by breaking it up into quadrants, or into 3 or 4. I'm going to see which one works better. I presume the 4 will work better. Whatever, I'm presuming it's the more hidden layers are going to work better. But there are two competing theories. Is one, I want a much wider first layer in order to approximate the function. And then maybe I don't need a whole lot of hidden neurons. Maybe I need like 5 times 5 in the hidden layers. That's one option. And then you can do a big, like maybe 10, maybe 20 on the first layer. That's going to be interesting to benchmark. There's a lot of interesting things to benchmark about that. But what am I going off about this? So I'm going to tie this back up to why I started talking about this is because I strongly regret not finishing my machine learning library, because I thought I had to be like TensorFlow. I thought I had to be like ARM embed with got all my fucking chips with my assembly language initialization script, and then I got my API that I'm building up over top of that so I can use any chip that I want. And then I'm gonna have to implement in now the Intel MKL math kernel library, and then BLAS, and then I'm gonna have to do the ARM Neon, do all of this shit in fucking assembly language and shit. And I'm like, I'm out, bro. Yeah, I totally thought that there's no way in hell that I could compete in this industry. But I've actually seen, now that I've seen what I can do with the 64-bit UUID library, that I have a different way to compete. In fact, I don't actually have to have all of those things. In fact, all I really need to do is do one thing better than everybody else, and then have it be able to work on a Beagle Y AI with an MPU, something that's like a 2 to 11 tops MPU. And then I can, instead of trying to compete where I'm trading blows with TensorFlow, trading blows with Qt, trading blows with Juice, with Microsoft, I'm what I should be doing instead is forming an alliance with one of these big tech companies, to where I'm able to do something with their chip that they can't do, because all these other libraries are really complicated to do everything, and they have a chip like this Beagle Y AI board that I got for $75. It's like a Raspberry Pi with a computer vision chip on it, and it's got 2 webcams, so you can do the 3D stereoscopic camera, which is very useful for training AI. I personally am trying to build a radar with it, ultra low power radar for my drones for Ukraine. So we're gonna do a software defined radio, and then I don't know. Then now I want to make my own transmitter for my RC stuff, because now that I see that there's a software defined radio that I can hack, they got an FPGA on it, and then I'm like, okay, I'm gonna have to throw in the towel if I keep adding on more and more things, because that's awesome. That would be totally great, but where am I getting time for that? I don't even have time for the other things, right? But I mean, I wish I would have had it done. I mean, I came up with a cool new LiDAR technology and a cool new stealth technology, and I think that this LiDAR technology, I might even be able to work with neural networks with it. Yeah, holograms and neural networks are very, very close, actually. So I'm looking into the holographic neural networks, which would require a $50,000 machine. I don't know, maybe I can make my own for $2,000, $3,000, maybe. That'd be badass. We'll see. And, if you can, basically what I want to do is I want to be able to do machine learning through holography. And so that's a whole can of worms right there. I haven't really gotten too far into this holography book. I'm like, it's still sitting here. In fact, it's got dust all over it. But this thing is crazy though, dude. Yeah, it's pretty technical. With a lot of math formulas and stuff. Woohoo! Oh yeah, I don't have mine. I have a document camera, but I can't hook it up right now. Okay, I've been yapping. What's the plan? I got to make an action plan though. You know, because I'm an old man. You know, like I gotta get the money, and then maybe find some young, like 30-year-old is like young to me now. You know, woman who could have a baby. Oh God, that's when you know you're like, oh man, it was a shorter ride than what I thought. So tomorrow, what's gonna happen today? I'm doing what am I doing? I'm doing the SUDA GPU programming on Coursera through Johns Hopkins. They got a specialization, so I'm trying to figure out now how to do the kernels with the SUDA, and then once I do the kernel, then I'll be able to make my random number generator work on the GPU too. And so my goal, excuse me, my goal is I would like to have a random a random number generator that I can run a supervisor AI. And then, so, neural networks need random numbers all the time. It's like a nonstop thing. So what I'm thinking is like maybe we could have a supervisor AI that's running in the background. And this is what is making me really regret ever stopping the neural network project, because, I have the neural network code. It's like all, basic stuff in C++, nothing advanced. But for some reason, I thought, I would need all this advanced math stuff on there, but I never really thought about doing it on the CPU and why you would ever want to do it on a CPU, because in my mind, that thought wouldn't have crossed my mind. I thought I had to do a GPU, but the thing is now they got new CPUs with MPUs, and like Intel's got the AI boost, on the computer that I'm on. I got the Core 7 Ultra 265K. I think it's a badass processor. Definitely the best processor I've ever had, bar none. It's excellent for video, and that is the number one reason to get it. If you're going to get one for video, that's one of the best. Definitely would spring for the Core 9 Ultra 285K if I could. But yeah, I think if I had really thought about that, if I had thought about making a neural network based random number generator, probably would have never given up on my API, because I can see that there's ways to get your API started that don't require you like just instantly being TensorFlow. You don't want to have like, you don't just want to like take an AI API and just like use an LLM to like port it and make it different just because you want to have your own API. Like that's just a horrible idea. You need a community of people behind it. And so this is going to start with you actually just needing to be able to do one specific application. And then you want to build it up from one thing to the next. So, having a legitimate reason to have a CPU based neural network based random number generator, that I think has opened up a lot of doors personally for my startup, because it allows me to breathe fresh air into the Script2 project, and it allows me to add a neural network to that layer of the API because I need a random number generator. Because as I mentioned earlier, I authored the world's fastest integer string algorithm, Puff the Magic Dragon, in the Script2 wiki on GitHub. Uses discrete mathematics to eliminate over half the division instructions from the mod 100 div 100 loop that the guy from Facebook, the head guy, said that they could not beat. So, yeah, because I have that other algorithm and I have to test it, I need random number generator. So that's one of the only things that I've been using of other people's code. And I really wish I would have put it together that I could generate pseudo-random numbers by doing floating point division. Because you got to admit, floating point division with values with a certain exponent range is probably the best way that you could possibly go about generating pseudo-random numbers, because the way those bits line up when you divide two numbers by each other, you just XOR 10 of those things together. Like, it's about as random as bits get. So I might not even need the neural network to correct the random numbers. They might just be so good that I might not need it. In which case, we're going to be running a supervisor AI in the background while in order to generate our random numbers. Business wise, was that all I wanted to say? I think it's like an hour and 12 minutes. I think I wrapped it up onto a business topic. Wasn't expecting to flow for so long on that. I haven't done a live stream in a long time that is just me talking. Usually I'm like live coding, and I used to do my own indie news show, RSS commentary, and then it got taken down. YouTube deleted my channel, and then Congress got my channel undeleted. So that will be coming back. I'm actually working on a news show right now about the DEI thing, that the Lost Generation article, and then going to talk about that MIT Brown University shooter, and about how he doesn't appear that it was motivated by Islam or by Palestine. There was speculation going around that it was Palestine. It does appear to just be just a random classroom that he picked, and it wasn't a target. We assumed it was targeted assassination of the VP of the head college Republicans, because the teacher was Jewish. The woman who was killed was Jewish. She was a known Republican in a campus that has very few Republicans. So it did appear on first sight like it might have had something to do with some pro-Palestinian craptivists targeting the teacher because she's Jewish, and then the college Republican VP was just happened to be there because she was Jewish too. We don't have any information about that. It just appears like the guy blamed the person who he killed at MIT for him not being able to get his PhD. But we don't know. So I think I'm going to end the live stream. Thanks for tuning in. This next one I'm going to do, I think I'll have it a little bit more cohesive around business stuff. I went off on some tangents, but I thought it was necessary. Like the whole lawsuit thing, that's kind of interesting. You can't deny that is one of the most interesting things going on right now. So until next time, as I say every time, farewell, aloha, au revoir, sayonara, And Godspeed in your jury's friend.